All right, well, how is everybody doing? I hope you missed me. Right now it is the end of a long day at Grimsley High School. But when you're seeing this, I will be sitting on a beach in the Bahamas. Yeah, I won't rub that in too often in the next couple days, just so you know. Now, what I want you to do is I want you to take a little quick assessment on the back side of those notes you took. I love the animations that you were shown in the video, how you could see the different atoms breaking apart and forming a chemical reaction. I want to assess how well you understood it. So the first thing I need you to be able to do, the I can statement, is I can identify the components of a chemical equation. And I'm just going to use the equation that he was using throughout in the videos there, combining water and oxygen molecules, combining hydrogen and oxygen molecules, and it formed a new substance, water. All right? So I need you to know where in this equation the coefficients are. I'm not going to tell you here, but what I want you to do, and pay careful attention because I'm going to look for this when I'm grading it, I want you to circle all the coefficients in each of those 5 equations that you have there for your assessment. If there is not a number there for a coefficient, remember chemists don't like to write ones. Will you do me a favor, add a 1 and then circle that if you do not see a coefficient in any part in any of those 5 equations. Now, after you do that, I need you to be able to tell me where the reactants are. Right? And a quick, easy way for you to show me where the reactants are is I would like you to put a line on top of the reactants. So any of those 5 equations, I want you to find the reactants, and I want you to put the line on top of it. You also need to know where in a chemical equation the products are. So in each of the 5, I want you to draw a line underneath. So line on the top will show me that it's reactants. Line underneath will show me that it's products. So take a couple of minutes, we'll pause the video, and then I got something else for you. All right, so now that you've done the different components of a chemical equation, the other thing I want you to be able to do is I want you to be able to determine if a chemical reaction has occurred. Now, there are some signs that you're going to see when you have the chemical reaction. The video gave you 6. Without turning those notes back over, no cheating, I want you to give me 4 signs or indications. You can do it just somewhere right at the bottom, just number it 1 through 4. I'll be able to tell what you're doing. Just give me 4 signs or indications that a chemical reaction has occurred. And once again, no cheating. Take a minute, all right, to do that. And then I got one more thing I want to talk to you about. Okay, so now that you've done this I can statement, I just want you to practice something to get you ready for tomorrow. Tomorrow you're going to learn how to balance equations. Right? And so what we're going to do today is I want to show you how to look at these equations and tell how many of each atom you have on the left side and how many atoms you have on the right side. Law of conservation of mass is good when the atoms on the left are the same as the atoms on the right. Okay, so we're going to just practice making sure you can tell how many of each atom you have. So I'm going to erase the middle here. And I just want to go through this equation with you for a minute and just to show you what I mean. All right. So here's our arrow. All right. That's the dividing line. We got atoms on the left. They need to equal atoms on the right. So this number in front, right, it goes to our hydrogen here, but also the little subscript is part of its formula. They both get multiplied together for a total of 4 hydrogens. Okay. Now over here, there's not a number. All right, so we know that there's 1 here, but there's 2 oxygens in that formula. On the left, 4 hydrogens, 2 oxygens. On the right, this number goes to the whole thing. The 2 only goes to the hydrogen, and there's not a subscript after the oxygen. So remember, it's assumed to be 1, they just don't write it. So for hydrogen, we got 2 times 2, we got 4. And for oxygen, 2 to that 1, the number in front goes to the whole formula. Okay? So there are 4 hydrogen, and there are 2 oxygen. And that's good because it's balanced, that's what's supposed to happen. I'll give you a hint. Same thing better happen on those 5 below there. I want you to go through and I want you to draw this dividing line where the arrow is. On the left, I want you to count up and figure out how many of each atom there are and write down how many of each. And then also do the same thing on the right. Make sure they're the same. This is going to get us good practice. If you can see this right away, it'll make tomorrow a lot easier. Now I do want to help you with one that can be a little bit trickier. So I'm just going to show you an instance. Let's say I have a compound, Ba, NO3, 2. That's a formula for barium nitrate. And let me just make up a big number here in front to go along with it. We're pretending it's part of a chemical equation. Let's just make it a 3. So what I want you to realize here, the 3 goes to every single thing in the whole formula. All right? But the 2 out here on the outside of this parenthesis gets distributed only in to the nitrate, NO3. The 2 will not go with the barium. Right? It'll go to the nitrogen and oxygen and nitrate, but not to the barium. All right? So be careful when you have something like that. Let's just do this really quickly. All right? Barium, I got nothing here, so it's assumed to be a 1. 3 times 1, a total of 3 bariums. For nitrogens, I got 2 of them because of this subscript outside the parenthesis here, times the 3 here in front. These 2 have to get multiplied for nitrogen. 6. And now oxygen, all right, we got 3 different things here that you got to worry about. There's 3 inside the parenthesis. There's a 2 going with it, so there's 6. But then you also have a 3 in front that goes to the whole formula. So 6 times 3, you have a total of 18 oxygen. So that's how you would do something like that. Maybe somewhere in a corner, kind of write this down to help you. There is a couple like this, and I don't want you to get stuck. All right, I'll see you next week. Bye.